Today's lecture covers the organization of the human nervous system. The nervous system can be divided into the central nervous system and the peripheral nervous system. The central nervous system includes those structures housed within the skull and spine. Specifically, we're talking about the brain and spinal cord. The skull and spine serve to protect the central nervous system. The central nervous system receives, stores, and analyzes sensory signals sent from the peripheral nervous system. It also generates motor signals that are sent to the peripheral nervous system. When we look at the brain only, it is comprised of the cerebrum, the cerebellum, and the brainstem. And it can be broken down and categorized in many ways. So again, we're looking here. Here would be the cerebrum. Here would be the cerebellum. And you can see extending beneath is the brainstem. The brain is also sometimes referred to as the encephalon. Encephalon, E-N-C-E-P-H-A-L-O-N, encephalon. The brain is gray in color and weighs about 3 pounds. You can see that the outer surface is covered with gyri, which are the bumps, and sulci, which are the grooves. Another term for gyri is convolutions or elevations. These occur because of the folding of the cortex. Another term for the sulcus or sulci, which is plural, is a fissure or groove-like depressions. Those groove-like depressions occur on the surface of the brain because of the folding that result in the convolutions or gyri and associated fissures, folds, or sulci. If the brain was to be laid out flat, it would be approximately 2,500 square centimeters, about the size of the New York Times or the LA Times, opened up and unfolded. The presence of gyri and sulci allow for more cortical space or area, that is, more cortex, within a smaller space within our skull. It used to be thought that the deeper the sulci were in an individual, the greater their intelligence, and shallow sulci related to people who were less intelligent. True or not true? You're probably guessing correctly that the deeper the grooves is not related to intellectual ability. The shape of gyri and sulci actually vary from person to person. Let's take a look at the central nervous system, the spinal cord portion. When looking at a cross-section of the spinal cord, you can see gray matter, which is the cell bodies, and they appear to form an H shape in the center, surrounded by white matter, that is, axons on all sides. So if we look at this next slide here, again, you can see in this cross-section in the middle, the darker gray area, the H shape in the center, is made up of the cell bodies of axons, also known as gray matter, and then you have surrounding white matter made up of axons. You can also see here I'm pointing out anterior horns of the gray matter and posterior horns of the gray matter. The anterior horns may also be referred to as the ventral horns of the gray matter. These anterior or ventral horns serve as a point of synapse for all descending motor tracts coming from the brain and the spinal nerves. The anterior or ventral horns are also known as the final common pathway because every motor tract that descends must synapse in the ventral or anterior horn on either side before exiting the central nervous system to the peripheral nervous system. You may hear the term tract. A tract refers to bundles of axons in the central nervous system, whereas a nerve refers to a bundle of axons in the peripheral nervous system. Become familiar with those. Tract, a bundle of axons in the central nervous system, a nerve, a bundle of axons in the peripheral nervous system. Now, if we look at the posterior horns or the dorsal horns of the gray matter here, these are a point of synapse for ascending fiber tracts and spinal axons. So, sensory information as it enters the spinal cord will synapse here. If we take another look at the white matter, you can see that there are dorsal regions, there is ventral white matter, and lateral columns. And these areas of white matter become passageways for different tracts that are ascending and descending within the spinal column. So looking back at this slide, we discussed the gray matter, points of synapse within the gray matter at the anterior and posterior horns. And then we also looked at the white matter made up of axons and how it can be divided into dorsal, ventral, and lateral columns. There's a little more information that I want to discuss while we look at this cross-section of the spinal cord. There are 4 bundles of fibers that emerge at each of the 31 different levels of the spinal cord. So here we can make a cross-section or a cut here. This would be one section of the spinal cord, and we have 1, 2, 3, 4 bundles of fibers that emerge from that section of the spinal cord. 2 bundles are sensory nerves and 2 are bundles of motor nerves. Posteriorly, we have the sensory nerves, and anteriorly, we have the motor nerves. So you have 31 pair of sensory spinal nerves and 31 pair of motor spinal nerves. Let's talk a little bit more about those sensory nerves. So sensory nerves, again posteriorly here, are bundles of nerve fibers that conduct signals from sensory receptors to the central nervous system. They enter the back side of the spinal cord, one from each side, and because they enter from the back, they are also referred to as dorsal roots. So this is a dorsal root, and this is the dorsal root. Nerves that carry signals towards a structure, such as nerves that carry information towards the spinal cord and towards the brain, are said to be afferent in nature. Afferent, A-F-F-E-R-E-N-T, afferent. Here are the bundles of motor nerves. The motor nerves are bundles of nerve fibers that conduct signals from the central nervous system to muscles and glands and other organs. They exit from the front of the spine, or the anterior portions of the spine. You can see them exiting here on each side. Therefore, they are also known as ventral roots. Nerves that carry signals away from a structure, so carrying signals away from the brain, away from the spinal cord, are said to be efferent in nature. E-F-F-E-R-E-N-T. All of these nerves carry both volitional or somatic information as well as subconscious or autonomic information. Peripheral nervous system can be further divided into the somatic nervous system and the autonomic nervous system. The somatic nervous system conducts signals to the central nervous system from external sensory receptors, such as information from your eyes, your ears, your skin, your joints. It also conducts motor signals that are sent to your skeletal muscles. The autonomic nervous system regulates the body's internal environment. It conducts signals from sensory receptors in your internal organs, such as your heart, your stomach, your liver, etc., to the central nervous system, and it sends motor signals from the central nervous system to your internal organs. The autonomic nervous system is responsible for those movements you don't have to think about. Things like digestion, your heartbeat. These things happen automatically. You don't think. Heartbeat, heartbeat, heartbeat. Oh, I just ate. Digestion, digestion. We don't have to work like that, and we don't work like that. Signals from the autonomic nervous system are conveyed on a subconscious level, whereas signals sent through the somatic nervous system are relayed to the highest levels of the brain, where that information is interpreted and purposeful or voluntary responses are generated. The autonomic nervous system is distributed throughout the central nervous system and the peripheral nervous system. This is also the system that dominates when a person is in a stressful situation. It can be further divided into the sympathetic nervous system and the parasympathetic nervous system. The sympathetic nervous system stimulates the body in preparation for danger, whereas the parasympathetic nervous system calms the body down to conserve energy. Here are the functions of the sympathetic nervous system contained within the autonomic nervous system. So, these functions include dilating your pupils, inhibiting tears, inhibiting salivation, activating sweat glands, increasing your heart rate, so forth and so on. You could read down the list. So these are the type of functions that occur if you think about the following situation. You're leaving campus, you're walking to your car alone at night after a late class, you hear footsteps behind you. You pick up the pace, the feet behind you pick up the pace. You notice your heart starts beating. Your breathing is quicker. Your blood is being redistributed to your larger skeletal muscles in your legs. Why? Your pupils are dilating. Why? These are sympathetic functions of the autonomic nervous system hard at work to get your body to be able to A, see in the dark, B, get your muscular skeletal muscles of your legs moving quickly so you can get away. This is the same reaction that you might have if you're driving your car and all of a sudden you hear sirens and you look up and see a cop car with its lights on behind you. So your heart starts racing. You get those butterflies in your stomach. But then when that cop moves around you and you realize, oh, he's not pulling me over, everything is copacetic and your body starts to calm down. That leads us to the parasympathetic functions of the autonomic nervous system. These are basically functions that are at work when you go to sleep at night. Most of these, as you read the list, calm your body down. Everything slows. Okay? Both of these work together to keep you and the nervous system working as a whole. This concludes the discussion for the general organization of the human nervous system.